All right, so we have been working on dividing decimals by whole numbers, and we're going to continue this process by adding another layer, another piece of the puzzle, another process that we need to do in order to be able to divide decimals by decimals. So we're going to look at the situation. Jenna buys candy bars for 54 cents each. Her total bill is $8.64. How many candy bars did she buy? So we want to divide up the total that we have in candy bars, and we want to break that into the cost of each candy bar to figure out how many we have. So we're going to start with a division problem, and we want to start with our total amount of money, which is $8.64. And we want to break that up into groups of 54 cents each, so 0.54. So there is our beginning problem, and we need to remember to set up the problem correctly. So we need to remember that the first term always goes on the inside of the division symbol, and the second term always goes on the outside. So we're going to set it up like this. Inside, $8.64. Outside, $0.54. So there's the problem we're going to be working with today. Now, we haven't dealt with a decimal point in our divisor. So we have to do something about this. And it's not really easy to ask how many times does 54 cents go into $8 or $8.64. So we're going to change our problem. We're actually going to write an equivalent problem by moving the decimal point in our divisor. Now, in order to do this, we're going to have to do some moving of the decimal point in the dividend as well. But we can do that. And we're doing that by, what we're actually doing is multiplying by powers of 10. So we're either going to multiply it by 10 or 100 or 1000. We don't have to do the math to do that. We can just use what we know about multiplying by powers of 10 and move the decimal point to get a new problem that is equivalent and has the same value, but is going to be easier for us to solve. So we're going to move the decimal to the right in the divisor until I reach the end. So I always want to start by moving the decimal in the divisor. So in this case, I have my decimal point, and then I have 2 decimal places. I'm actually just going to go ahead and rewrite that down here. And we'll see in a minute that that's one of our steps, is to rewrite the new division problem. But I'm actually going to change this to a 54. Now, I can't change this number to a 54 without also changing the dividend. If I'm going to do a change to one number, I have to do a change to the second number, and I have to do the exact same change. So what I actually did here was multiplied this by 100. So I need to do the same thing here. Multiply it by 100, or I could just remember that I can move the decimal point 2 places. And so it's going to become 864. My decimal point doesn't go away. It's here at the end now, and I may need that when I do my final answer. But for right now, we now have moved the decimal points in both numbers. So we move the decimal point to the right in the divisor. We move the decimal in the dividend the same number of places. Make sure you're filling these things in your notes. Step 3 says rewrite the new division problem. I did that as I was working, but when you're finished, we don't ever leave these jumping marks in our math problems. We always want to, we always want to rewrite the problem so we have a clean, neat problem to work with. All right, so step 4, we're going to go back to what we learned about dividing by whole numbers. We're going to place the decimal point in the quotient directly above the decimal point in the dividend. So I'm going to move that right up there. And now we're going to divide. We're going to go back to pretending like there's no decimal points. So we're going to divide as if there are no decimals. decimal points don't go away. We don't erase them, but we just ignore them for a little bit. So I'm going to ask myself, how many times will 54 go into 8? It doesn't. How many times will 54 go into 86? And I know that 50 times 2 is 100. That would be too much. So I think 1 is going to be the answer that I'm looking for. So 1 times 54 is 54. And I'm going to subtract. 6 minus 4 is 2. And 8 minus 5 is 3. So I'm left with 32. And I need to ask myself, is 32 smaller than 54? Then the answer is yes. So that means I've done the right math. And I'm going to move on and bring down my 4. All right, now I'm going to do a little bit harder math. I've got to do some estimating. And I've got to think about how many times will 54 go into 324? Well, I don't have any idea. But I'm really good at counting by 50s. So I can think about 50s, because 54 is close to 50. How many times would 50 go into that? And I think, okay, well, 50 goes in there. 2 times would be 100. So 4 times would be 200. And 6 times would be 300. And that's going to get me pretty close if I estimate. So I'm going to start with 6 and say 6 times 54. I don't know what 6 times 54 is. So I'm going to have to do that math problem off to the side to make sure I get the correct math. And so 6 times 4 is 24. 6 times 5 is 30, plus 2 is 324. And that works out perfectly. I subtract with the remainder of 0. 0 is less than 54. There's nothing left to bring down, so I know my answer is, I have 0.16 decimal, and I know the way that's written, that's not how I'd want to write that for my final answer. I actually just want to write the numbers I need and leave out the extra zeros or decimal points. So in this case, the answer is just 16 candy bars. All right, so let's look at the rest of our steps. Place a place a 0 in front of the decimal point if the quotient is less than 1. Well, in this case, my quotient is not less than 1. I have my decimal point here, and in front of that, I have numbers already, so I don't need to do that. And I'm going to use estimation to check my answer. And I know if I had 16 times 50, I would be close to 800. So, or I would be at 800 actually. So I know that is going to get me close. So when I do 16 times 54, I'm going to be right at about the answer I need.